Let's have a quick recap about this side quest of building the CLI tool for PC-to-PC messaging. Since this is part 2 of this side quest, I would highly recommend you to check out part 1 first. If you want to download the code from my GitHub repository, link in the description. Anyways, here's the recap. I have 2 computers. One is running Kali Linux in VMware under Windows 11. The other one is running Arch Linux. For the Kali Linux virtual machine, I set its network mode to bridge mode so that it can have bidirectional communication with other computers within the same local network. For the program design, it consists of 2 modes. One is the sender mode, which takes 2 command line arguments, target IP address and message string, for sending the message to the target. Another one is the listener mode, which takes no command line argument and passively waiting for incoming messages. In terms of the code, I demonstrated the simple standard input-output library as the header, the main function that takes in command line arguments, the conditional statement for entering into different modes, i.e. sender mode, listener mode, and the error case, and the run sender and run listener functions for actually doing the tasks of sending and receiving messages. Now, let's focus on the run sender function this time. In order to successfully send a message to the target, not only the sending system needs to be running the program in the sender mode, but the receiving system also needs to be running the program in the listener mode. However, this is not sufficient for modern computers, because computers nowadays are built for running multiple programs at the same time. So on top of the IP addresses, ports are introduced to identify different applications. Combining the IP address with the port with either TCP or UDP, a socket is obtained, and a communication channel between 2 programs over the network can be established. Thus, I would like to create a socket with a socket function by including the syssocket.h system header file. The following is the prototype of the socket function, which takes 3 parameters. Let's dive into each of them. The first one is domain, which specifies which protocol family to use. The common ones are IPv4 Internet protocols and IPv6 Internet protocols. The other ones include but not limited to Apple Talk, Bluetooth, and amateur radios. The second one is type, which defines the semantics of communication, whether it's running reliable connection oriented for TCP, connectionless unreliable for UDP, or other types, such as raw network protocol access and reliable delivered messages. Finally, it's the protocol, which specifies the specific protocol to be used with the socket. Usually, it's set to 0 to use the default for the selected domain and type, but there are also some other options. You may find it weird that all of these parameters take integers, but we put something else inside to use it. This is because these symbolic names are predefined in the syssocket.h system header file. Each of them represent a corresponding integer. In the case of this project, I choose to use IPv4 for the domain, connectionless unreliable socket type for UDP, and set the protocol as default. After putting all of these into the function, it will return an integer. If the socket is successfully created, the returned non-negative integer would be the socket file descriptor. If the function fails to create a socket, it will return -1. So let's define an integer variable as the socket file descriptor, which will be used for accessing the socket I create here, by assigning the return value after creating the socket as I mentioned before. Then write the conditional statement to check whether the socket is created successfully. If not, then print socket creation failed and return to the main function. Now that I have created the socket with no IP address and port assigned for the moment, only UDP is chosen for the protocol. The next step is to let the program know the destination of the message. In particular, the target socket consists of the target computer's IPv4 address, the port number for the target program, which I pick 1234 for the moment, and the protocol for the communication, which is UDP. To store all of these information for later usage, I need to introduce another header file for the structure of an IPv4 socket address, which contains 4 entities. 2 bytes for address family, 2 bytes for port number, 4 bytes for IP address, and 8 bytes for padding. So in total, one of this structure occupied 16 bytes. Let's first define the destination address in this structure, then plug in the corresponding values for each slot to see how it works. After defining the destination address without assigning any values yet, it contains 16 bytes of unknown random values. To clear these 16 bytes, I introduce yet another function from string.h header file, which will set the first n bytes of the block of memory pointed to by s to the value of c. In my case, I set the whole memory block of destination address to the value of 0. Then assign the address family to IPv4, which uses the same symbolic name as the domain in the socket function. In the case of the port number, instead of using little endian byte order, which puts the least significant byte first and is commonly used in modern computers, network protocols use big endian byte order. So another header file is introduced for a function to convert the little endian byte order to the big endian byte order, so that it will be compatible later for sending messages through the network. And as I mentioned before, I set the port number as 12345. The last piece of information needed to be plugged in is the target IPv4 address. There is a particular function for converting a null-terminated IP address string to its binary representation, then store it to the desired destination. The first parameter of the function is the address family. Again, I put IPv4 in here. The second parameter is the pointer to the null-terminated IP address string, which I put the pointer to the first command line argument passed down to this run_sender function. The third one is the pointer to the buffer where the binary representation will be stored. There are 3 results for this function. If the IP address string converts to its binary representation successfully, the function will return 1. If the string is not a valid IP address in the specified address family, the function will return 0. If an error occurs instead, the function will return -1. So I can write a conditional statement to check if the function runs successfully. If not, I can print invalid IP address format, close the created socket, then return back to the main function. Now I have created a socket for sending the message and store the destination address in the correct format. The last step is to actually send the message. I use the send_to function from the syssocket.h system header file. Here I omit quite a lot of explanation about the types appear in this prototype. Let me know in the comment section if you want me to dive deeper into those details. The first parameter is for the socket file descriptor. The second one is for the pointer to the buffer containing the message to send. The third one is the length of the message in bytes. The fourth is for modifying the behavior of the send operation, which in this case I use the default one. The fifth is the pointer to a socket address containing the destination address. However, the structure this function takes in is a bit different from the one I created. It is instead a more general one, where the one I created earlier is specific for IPv4. This is the reason why the structure created earlier has an 8-byte buffer for matching the more general form. So here I need to change the type to the more general format. The final one is for the size of the address structure. Since the function will return the number of bytes sent if it runs successfully, and will return -1 if there is an error, I can save the return value and use it in the conditional statement for printing out the result. If the function fails to run, it will print send_to_failed. If the function runs successfully, it will print message sent with the number of bytes follows. Finally, close the socket created, then the whole operation of this run_sender function is finished. Thus far, by calling the function in sender mode with the appropriate IPv4 address and the message string, the function would send a message to the destination. However, one might wonder why I haven't explicitly assigned the IP address and the port number for the computer that sends the message. The reason being that the send_to function automatically figures this out if no socket is explicitly bounded. The case will be totally different for receiving a message, which I'll cover it in the next video. So that's it for this time, and see you in the next one about the run_listener function.